Your homework that you had on yesterday, it should have been fairly easy considering the fact that you had enough notes to assist you. And it was difficult, but no one ever died from difficult. It was challenging, but no one ever died from challenging. You did have to apply your knowledge and apply your notes to it. There's no one that's absent, right? Okay. So today we are going to do an assignment called Who's Your Daddy? And with this assignment, this is going to help you bring it to life and have a better understanding. So how many of you ever watched The Maury Show? The famous line, you are not the father. So here at Can't Get Right Hospital, there has been a mix-up at the hospital and some babies have been switched at birth. So it's not an instance where the mother is carbon-like and can't figure out who her baby daddy is. It's more our fault at the hospital. Parents had the baby, we took them to the nursery, and we kind of made a mistake. So it is your job as a geneticist to be able to figure out who that baby daddy is and who will be the baby mama. So what you're going to do, you have a sheet in front of you, and in front of you it says, in order to match these babies with their proper parents, you must first determine the baby's possible genotypes. What's a genotype? Now, be more specific. Represented by what? Alleles. And what do those look like? Letters that are looking like what? Capital, which represents? And then another letter, which represents? Recessive. So we are going to look at these genotypes for each trait, and we're using the following symbols to represent specific traits for dominant and alleles that we're going to be looking at. We're going to be looking at things like widow's peak. Anyone knows what a widow's peak is? What's a widow's peak, Ayana? The hair that comes in the front. Vernon, turn around. Vernon does not have one. A lot of gentlemen get theirs cut to even their hairline out. Cam does have one. Yes, you do. You cut it. Yeah, you do. Luis, pull your hair back. Oh, he doesn't have one. Essence does have one. Terrence, turn around. Nope. Greg? Nope. Janae has one. I don't have one. Leon has one. So that is what a widow's peak is. And when we look at this areas around. When we look at the widow's peak and we look at the information that we have on our sheets, we notice that having a widow's peak is a dominant trait. All right? Not having a widow's peak is a recessive trait. So the fact that I do not have a widow's peak, what's my genotype? Recessive. Recessive. All right. What is Leon's possible genotype? Dominant recessive or? Dominant dominant. All right. Earlobes. Free earlobes or attached earlobes. Free doesn't mean that we didn't pay for them. And so we just got them for free. Free means that they're hanging and they're not attached to your face. A lot of people have free earlobes. It is a dominant trait. There are a few people that have attached earlobes. So let me come and see. Nope, you have free earlobes. Let me see yours. Free earlobes. Oh, this would be a little bit of an example, not all the way of an attached. It does hang a little bit, so she has a mix between both. What would that be? What kind of dominance is that? It could be co or incomplete. We don't really necessarily know with this instance here because it's not like the color for the roses where you have both colors and when you have a mixture of a color. Renisha has attached earlobes. So you go right there. So her genotype would be what? Recessive, recessive. My genotype would be what? Dominant, recessive, or? Dominant, dominant. All right, so let me then introduce you to the babies because for the babies, we have to figure out their possible genotypes for each trait. Baby number 1. Baby number 1 does not have a widow's peak. Take a moment and write the possible genotype. What are the possible genotypes for this baby? What are the possible genotypes for this baby if he does not have a widow's peak? Recessive W, recessive W. That's it. Because if it was dominant W and recessive W, then he would have no widow's peak. All right. This baby has attached earlobes. The reason why we're looking at these specific things is because with babies, they haven't fully developed or bloomed. Some babies are bald heads, so we don't even know what color their hair is or anything like that. So we're looking at these things that we can really notice in the area if they have hair and stuff like that. But attached earlobes, what's his possible genotype? You don't need to see the baby. You have the information. I'm telling you that his earlobes are attached. Recessive E, recessive E. His blood type is A. Let's fill that in. Isn't that what it says? Why can we not look here? This is the information for the babies. Shh, too much extra talking.
So do we use A or?
Huh? You just write his blood type. A. There's no genotype for that. Now let me explain for blood types. If you don't remember, when we talked about blood types, there are four particular blood types. What are they? A. Stop being weird. A, B, O, and B. All right. Now, what these blood types are, remember, the blood types are antigens that are hanging really off of your blood. These antigens are hanging off to be able to match or recognize different diseases and get rid of those diseases. Now, if you are type A blood type, your possible genotype is actually A and O, because O means you do not have any antigens. All right? There are two specific spots because remember, you get one from mom and one from your dad. So you're getting A and you're getting O. That's mixed together. So therefore, your offspring's particular blood types can either be A or O. If you are a B blood type, then that means that your genotype is going to be B or O, meaning you have the B antigens, or you could have gotten no antigens, which means that any of your offspring, if you are linking up with somebody that has the same blood type, but the offspring's possible blood types could be B or O. Now, if a particular person has an AB blood type, so let's say you are someone who had an AB blood type, your parents would not have had O. Remember, there's only two spots for it. So your parents either had to be what? A, B, or AB. Make sense? If you are an O blood type, that would mean that your parents could have been O. It could not be A or B because of the simple fact that it would pull in one of those antigens. Got it?
Right. That's the same thing for people that have sickle cell.
We did that yesterday. We figured that out on our notes yesterday. Remember? Yeah. All right. Let me introduce you then to baby 2. Baby 2 is no widow peak. We might need to fire you. So he has no widow's peak. So what would his her genotype be for? Recessive W, recessive W. What about the earlobes? Free earlobes, meaning they're hanging like mine. Dominant E, recessive E, or dominant E, dominant E. Blood type is B. So far, so good? All right. Let me then introduce you to baby 3. Here we have baby 3. Baby 3 has a widow's peak. Therefore, baby 3's genotype would be dominant W, recessive W, dominant W, dominant W. Are you this baby's daddy? Then what you talking for? Yes. I don't have no idea what you're talking about, sir. Free earlobes. So what are the genotypes for the free earlobes? Dominant, dominant, or dominant recessive? You tell me. I'm not answering it for you, Shamika. You have enough information. We've done enough of this for you to figure it out. Let me introduce you to baby 4. Baby 4 has a widow's peak. What's the genotype? They're all W's. Dominant W, recessive W, or dominant dominant W. Baby 4 has attached earlobes. Recessive, recessive. And baby 4 has a blood type of O. So far, so good? All right. Now, before we move on, let me just fix something on your paper if you turn over to the back, because I'm going to introduce you to these couples so that we can figure out their information and so we can link these babies to the right couple, because we can't keep them here. We don't have enough milk. Looking at the back of your paper, you have a couple named Michael and Aaron. We need to change that couple's name. We can't get right here, so we made a mistake. That last couple that you have on your paper, their name should be Greg and Maria. The last one on the back. So that in the middle of the paper, it says Michael and Aaron, change that to Greg and Maria. In the box, change that to Greg and Maria. Looking down at the very bottom where it says parents, down there it says George and Maria, change that to Greg and Maria. So far, so good? All right. Then let's go ahead and look at these couples. The first couple that we're going to look at is John and Julia. No, tell me later. So here is Julia. And John, we're going to keep him a mystery for a second, only because of the simple fact is I want you to use genotypes to figure out these parents and not identifying their physical traits. Because babies may not necessarily look like their parents right away, or they may not look like their parents at all. That happens. But we will be able to identify who their parents are if you're good at your job. So I do have the information for his genome, what he looks like, but I don't really know what he looks like right now, physically. So, for Julia, looking at our paper, make sure you're putting it in the right box. Julia does not have a widow's peak, therefore, what are her possible genotypes? Recessive, recessive. You need to write it in the box where it says John and Julia, determine John and Julia's possible genotypes. Earlobes. Julia has free earlobes. Dominant, dominant, or dominant recessive. Her blood type is AB. So far, so good? All right. John, the baby's daddy, has a widow's peak. What is John's possible genotype? Dominant, dominant, or dominant recessive? Fill in the box. Get some mashed out for somebody so when they come in, we just give it to them and keep it moving. All right. So what is the genotype for John's earlobes? They're attached. Recessive, recessive. All right, his blood type is B. Moving on. You are going to now take a moment and determine the possible genotypes for their offspring. Create a Punnett square if you need to. You're going to talk amongst your group of members at your table. On the side, if you need to create a Punnett square for each type, you need to go ahead and do that so you can determine what are the possibilities of their offspring's genotypes. Go ahead and do that now. Asia. I know. We're busy. We never go to the bathroom during the lecture. All right. Then let's look at the possibilities of the offsprings having a widow's peak. What would their genotypes be? Dominant recessive or recessive recessive? Dominant recessive or recessive recessive? Is that true? Yeah. Because we have John has a widow's peak. A widow's peak is dominant. So John's genotype could be dominant W, recessive W, or dominant dominant. So therefore, when you do the Punnett squares, you can end up with the dominant recessive, and you also can end up with a recessive recessive. When you link them all, you have to do two Punnett squares. All right. What about the offspring's earlobes? Dominant recessive, recessive recessive. So they could have one with the widow's peak or one without. Just like the parents. One could favor the parents, one wouldn't. So on and so forth. What about the blood types?
It'd be either A, B, or O.
Not O.
Or B.
It could be A,
B, or B.
A, B, or B. Because remember, the dad is BO. The O is invisible because you don't have a blood type that looks like that. So when you do a Punnett square, they're all going to either have an A there. If it says AA, that's A. If it's AB, that's AB. If it's just a B, then a BB, then that's B. There's never going to be a possibility of it being blank. All right. Let's then now look at our next couple, Michael and Aaron. Meet Aaron. Michael, again, we're not going to reveal his identity only because we need to have true information and not biased information. But for Aaron, she has no widow's peak. What's her possible genotype? Recessive, recessive. For Aaron, she has an attached earlobe. Recessive, recessive. Her blood type? AB. For Michael, he has a widow's peak. Dominant, dominant, or dominant recessive. His earlobes are also attached. Recessive, recessive. His blood type is A. Take a moment and figure out the possibilities of their offspring on the back. Kim, I should hear you communicating as well and not waiting for the answer. All right?
Pardon the interruption, teachers. Please make sure that you check your emails. Today I sent out earlier the out of gear list. Please make sure that you include
Alrighty.
students that are on the list.
What are the possibilities for the
What their status is tomorrow. Thank you.
what are the possibilities of their offspring having a widow's peak?
100%.
Is it? It's not.
Dominant recessive.
It's a 50% chance because they would have dominant recessive genotype or recessive recessive. So they could have one or the other. What about the earlobes? Their baby totally is going to have attached earlobes. 100%. What about the blood type? A, AB, or B? Let me introduce you to Greg and Maria. Here's Maria, here's Greg. Again, we're keeping his identity secret so that you can just go on your data. Maria has a widow's peak. What's her possible genotypes? Dominant, dominant, and dominant recessive. What about her earlobes? So what's her genotype? Dominant, dominant, or dominant recessive. Her blood type is A. Greg has no widow's peak. Recessive, recessive. Greg has free earlobes. Dominant, dominant. Dominant recessive. Greg's blood type is B. Blood type is B. All right. We'll do the possibilities of the babies together. What are the possibilities of the baby's genotypes? Dominant, dominant? It could never be dominant, dominant because Greg is recessive. Dominant, recessive, and recessive, recessive. What about the earlobes? This can be dominant, dominant, recessive, recessive, or dominant, recessive. The blood type. A. A.
Or B.
Or
I
B.
mean, A, B. A, and O. A and B. A and O. Like, that's not A and O.
What is it?
O. There's an O.
It can be A, B, B, and O. Because when you do the Punnett square, remember the Punnett square is going to have the dad is going to be B and O. The mom is going to be A and O. And therefore, the first box is going to combine the two, AB. The second box is going to be AO, which means the blood type A. The bottom box is going to be BO, which is blood type B. And the third box is going to be OO, which is blood type O. So it can be all of them. Got it? All right. Take a moment within your group, your partners of geneticists, and decide who are these babies' daddies. We need to figure this out. Use your data. Figure out these baby daddies and mamas.
We're doing the very last box now?
Yep, you got to figure out who belongs to John and Julia, who belongs to Mike and Aaron, and who belongs to Greg and Maria. I know at Can't Get Right Hospital, we have one baby that we probably still don't know who them parents are.
Yeah, it can't be baby three because it has a widow's peak. And if you, so Julia and John, they basically want a widow's peak. Michael and Aaron, they have Julia has a If they have widow's peak, maybe it's have a widow's peak, and it won't have a test earlobe, and it will have those leg, yeah.
In case you didn't hear me again, at Can't Get Right Hospital, notice we only have 3 sets of parents. There's a baby that we won't be able to match up. We can't get right. Maybe you'll take it. Take about 2 more minutes.
It's a possibility that it won't have, it will have. It could be but it could have a test. And then the blood type of A, B, so
Not Georgia Marie, it's Greg and Marie.
yeah, what we're saying, maybe 30 lost.
30 seconds. Never go to bathroom in a lecture.
Maybe one didn't have,
You have to wait until after class.
Miss Wiggins? Maybe one, didn't have test earlobe.
Attached earlobes everyone had. All right. We do have a bit of a commercial break. So for our commercial break, remember we said that it is a possibility that babies do not look like their parents because of the simple fact is that it may pull, if both parents have the recessive gene, it may pull the recessive gene from the parents and end up developing or showing that recessive trait. Like we looked at our notes yesterday where we had sickle cell, where the child could have the sickle cell, but the parents do not. They're the carriers of that gene. It is also possible that siblings may not look anything alike. Why? Why will siblings possibly not look alike? Exactly. It is also a possibility that twins won't even look alike. So here are some examples of a black and white twin. They're born a minute apart. They are twins. Both parents have a white mother and a black father. This is how they came out. Another example of another twin. These are not the same twins, but it's another example of a black and white twin. Here's their entire family where they favor, but they don't look exactly alike. And these are 2 teenage twins that don't look alike. You have Lucy and Elmer. One is white skin with red hair. The other one is, Lucy and Maria, Elmer is their last name, with thick curly hair. Another example would be here. Here you have twins. He could say, hey, I'm taking you on the Maury show. However, they were born at the same time. And here you have an example where 2 black parents had a white baby. It is very possible. Now, back to our regularly scheduled program. In the case of Julia and John, the famous words of Maury would be, you are not the father, or you are the father. So we're going to determine who belongs to Julia and John? Would John please stand up?
Louis.
In the case of Julia and John, baby 1, you are not the father. Baby 2, you are not the father. Baby 3, you are the baby's daddy. Make sure on your paper you put baby 3 for Julia and John. All right. In the case of Aaron and Michael, will you please stand up? For baby 4, is baby 4 Michael's baby? You are not the father. For baby 3, you are not the father. For baby 2, you are not the father. For baby 1, you are that baby's daddy. All right. In the case of Maria and Greg, would Greg please stand up? For baby 1, you are not the father. For baby 2, you are not the father. For baby 3, you are not the father. For baby 4, you are that baby's daddy. All right. I hope that this made sense to you and helped you out. You do not have homework tonight.